diatomic gas confined to a cylinder. It's subjected to a closed cycle. What that means is it will end up back at the same conditions it started at. So initially the gas has an initial pressure of P naught, an initial volume of V naught, and an initial temperature of T naught. It's going to get back to those same values. First, the pressure is tripled under constant volume. So the first part of the process is isochoric. Then it expands adiabatically to its original pressure. So the volume will increase until it gets down to the original pressure. The final step is isobaric. The gas is compressed isobarically to its original volume. We want to know what the net work done is for the cycle. If we were to graph this cycle, PV diagram, we start at some initial pressure P naught and some initial volume V naught. The pressure triples. So we go up to the point where the pressure is tripled, but the volume is the same. Then we expand adiabatically until we get back to the same pressure. And then we go back to this original volume. So that's what a rough sketch of the diagram looks like. The net work done is that area in there. It is not zero. It is the net area under the curve. Okay? To find the net work done, we can add the work done in the first step, plus the work done in the second step, plus the work done in the third step. And that will give us our net. We will need to know more information about these other steps though. For example, we know the temperature at the first step is T naught. Up here we have a volume of V naught, we have a pressure of 3 P naught, so what will the temperature up here be? If you have the same volume but triple the pressure, you have to triple the temperature. Exactly right, 3 T naught. So down here we need to figure out what volume and temperature we have at this point as well. To do that, this part of the process is adiabatic. In an adiabatic process, we know P1 times V1, so the pressure times V to the gamma at one point in the process has to equal P2 times V2 to the gamma in the second point of the process. Here's the first point. The pressure is 3 P naught. The volume is V naught. Gamma, this is a diatomic gas, so we know that gamma is 7/5. P2, point 2 is going to be the end of our adiabatic cycle. The pressure at that point is P naught. We're back to our original pressure. We're looking for V2. P naught's going to cancel. How do I get rid of the 7/5 power? Take it to the 5/7. We need to do that to both sides. The 7/5 to the 5/7 power, remember when you take a power to a power, you multiply them. When you multiply 7/5 by 5/7, you're going to get 1. So we're going to get V2 on this side. We need to take the 3 to the 5/7 power, but V naught's to the 7/5 to the 5/7. So we'll just get V naught there. So 3 to the 5/7 is what we need to know. 3 to the 5/7. 2.19 V naught. Okay, any questions on finding the temperatures at any of these points? So we found the temperature at the end of the adiabatic cycle is 2.19 T naught. Volume at the end of the adiabatic cycle, 2.19 T naught. So we know P, T, and V in terms of P naught, V naught, and T naught at each point. Questions on any of those? We need those pieces of information to solve for the work in each step. So, work for step 1. This is step 1. It's an isochoric process, constant volume. How much work is done if your volume is held constant? 0. That one's easy. I like that one. Step 2. Step 2 is our adiabatic process. What information do we need to know to find the work done in an adiabatic process? What characterizes an adiabatic process? Number of moles is constant. Q is 0. So if Q is 0, then work has to equal the change in thermal energy. First law of thermodynamics. Q plus work is equal to the change in thermal energy. If Q is 0, then work has to equal the change in thermal energy. This is a diatomic gas. The equation for change in thermal energy is 5/2 nR delta T. Delta T is the final temperature. So the temperature at the end of the adiabatic cycle, so 2.19 T naught, minus the temperature at the beginning of the adiabatic cycle, so minus 3 T naught. I'm going to multiply that out. Huh? But multiply it by 5/2 too. We're at it.
Minus 2.025.
Our answer cannot be in terms of N and R though. We were told our answer can be in terms of P naught, V naught, and T naught. But what is nRT naught? PV. So, negative work, negative 2.03 P naught, V naught of work is done in the adiabatic step. So energy is leaving our gas during that step. The third step is isobaric. Isobaric pressure is held constant. How do we find work in an isobaric process? Negative P delta V. So pressure, that whole step is P naught. Delta V means V final, which is V naught, minus V initial, which is 2.19 V naught. 1 minus 2.19 is going to be negative 1.19. Negative signs will cancel. So the work during that step is positive, 1.19 P naught V naught. Let's add them up. 0 minus 2.03 P naught V naught plus 1.19. Sorry, plus 1.19. That's the net work done in this cycle.
In 3.
No, this is total overall. This was 3. So work 1 was 0, work 2 is negative 2.03 P naught V naught, work 3 is positive 1.19. So when we add them all up, the net work is negative 0.84 P naught mu naught. Negative means throughout the course of the cycle, energy left the system by way of work. So the system did more work on the surroundings than the surroundings did on it. Any questions?